Now, we're still missing many people, but we're just going to go ahead and start. So when you have a problem, linear differential equation with fixed coefficients with right-hand side, and the object we are dealing with is ay double prime plus by prime plus cy equals f of x, where the function f of x has either this form or that form, then again, we will have to start by step 1, solve the homogeneous problem. Ay double prime plus by prime plus cy equals 0, for which, of course, we have the Euler equation a lambda squared plus b lambda plus c equals 0. And we get the roots of this equation. And then we write the general solution. So assume y of x is the solution of this one. Then you go to step 2, you're going to find a particular solution. Yp of x. Now, how do we find yp of x in this case? Same as in the previous cases, we need to find a function that involves some constants that we are going to look for, which is why we have method of undetermined coefficients. So, and no matter the case, this or that, our yp is going to have the same form. So, and that form will be depending on whether alpha plus I times beta, alpha being the one from the exponential and beta being from the cosine, is not solution of a lambda squared plus b lambda plus c equal 0. If alpha plus I beta is not a solution of that, then we are going to say that yp of x is a polynomial of degree n e to the alpha x cosine of beta x plus another polynomial of degree n e to the alpha x sine of beta x. And again, I say and emphasize that it doesn't depend on whether here I got cosine or I got sine. No matter which of them is present, I'm always going to look for a particular solution in the form polynomial of degree n times this and another polynomial of degree n times that. Sorry about that. I think that's someone trying to reach me on Facebook about the information. So again, the common mistake that students have here is to take the same polynomial for the two. Now it's one polynomial, a completely different other polynomial. They have the same degree, they are not same. In case number 2, if alpha plus I beta is a solution of A lambda squared plus B lambda plus C equals 0. Then the solution is going to be written as yp of x equals x first and then polynomial of degree n e to the alpha x cosine of beta x plus x times another polynomial of degree n e to the alpha x sine of beta x. That's it. Once you have the proper formula for yp, then you go to the next step, you take derivatives. Then you go to the next step, you track the coefficients. And solve for the constants. That's it. That's the full method. Again, it has two pieces. Now, the other thing you need to know is it might happen that your polynomial of degree n that you have at the beginning is just a constant. In that case, you just have e to the alpha x and sine beta. Or you might not have e to the alpha, which means alpha is 0. So when you don't have e to the alpha x, you understand that your alpha is 0. Now let's work this through some examples. So we have example 1. Y double prime minus 2y prime equals cosine of 2x, for example. In this case, your alpha is 0 because you don't see any exponent. So right there, you get alpha equals 0 and beta equals 2. And the polynomial is of degree 0 because you don't have any powers of x here, so you get n equals 0. And now you start solving. Step 1, the Euler equation is lambda squared minus 2 lambda equals 0. That's the problem that you solve. So you solve this, you get lambda equals 0, or lambda equals 2. 2 distant roots, so that means capital Y of x, which is the general solution of the homogeneous problem, is going to be C1 e to the 0x plus C2 e to the 2x. So that's the solution of the homogeneous problem. Then you get to the second step where you want to find a formula for yp of x. How do I find that? I need to check one thing. Alpha plus I beta, is its solution or not of the Euler equation? And so alpha here is 0, beta is 2, so that is 0 plus 2i. Is this a solution of the Euler equation? The answer is no, it isn't, because there's no I here. So this is not solution. And because it's not solution, we are in the first case where we don't need to multiply where we don't need to multiply by x. So what we need to do is take a polynomial of degree n. N is 0, so polynomial of degree 0 is a constant. Polynomial of degree 0 is another constant, so I need two different constants there. So it's going to be a cosine 2x plus b sine 2x. So that's what a particular solution would look like in this case. And now you go to the third step where you take the derivatives and then you go track the coefficients. So in that third step, the derivative is negative 2a sine 2x plus 2b cosine 2x. Then you take the second derivative. It's going to be negative 4a cosine of 2x minus 4b sine of 2x. So those are all the derivatives that you need in this problem. So you move to the last step where you track the coefficients. You're going to track the coefficients of cosine 2x. You're going to track the coefficients of sine 2x. That's it. You want to track the coefficients, you need to follow the equation. Second derivative, cosine of 2x, you go to the second derivative, you look for cosine 2x, and that coefficient right there is minus 4a. Then you go to the derivative, minus 2. You go to the derivative, you look for cosine 2x, that's 2b. Nothing else equals, right-hand side of the equation, you got cosine 2x, 1 coefficient. Then you look at the second problem, sine of 2x, you go to the second derivative, sine of 2x is minus 4b. Then minus 2. Then you go to the first derivative, you look for sine of 2x, that's minus 2a. Equals 0. Because on the right-hand side of that equation, you don't have sine 2x. So this second equation solves into a equals b. You take that into this equation. You take that equality into this equation, it gives you minus 8a equals 1. So a is minus 1/8. And a is equal to b, so they are. So in this case, you got yp of x equals minus 1/8 cosine 2x minus 1/8 sine of 2x. That's it. That's the particular solution of the problem. And now you get to write the solution of the problem. Y of x equals capital Y of x plus yp of x. Capital Y of x is found in the first step. So that's C1 plus C2 e to the 2x plus yp, which is minus 1/8 cosine of 2x minus 1/8 sine of 2x. Any questions? Is this making any sense there?
Yes, sir.
Yes, sir.
All right. So technically, this is the procedure, and that's what you expected to do when you have problems like this. Now, let's say we just have to take a few problems, and I ask you to write down the YP, figure a formula for YP, because that's the most important thing. If you miss the formula of YP, then everything else you're doing is wrong because you're dealing with the wrong formula. So most of the time, I'm going to be asking you to just write down a formula for that YP from different problems. Let's say we have second derivative plus y equals x cosine x plus e to the x. And I say, okay, give me the formula for yp of x. So please take a few minutes to work on this. And remember, as I said at the end of the previous lecture, when you have two different functions like this, that means you need to write yp for each of them and then add them to get yp for the whole equation. So there are two pieces in this problem. Anyone ready to propose a solution? Do we have anyone ready with a solution? I'm not asking to solve for the constants, just asking to write a formula for YP. Want to try with me, Michael?
I don't feel confident in my understanding of this to answer.
That's the first step. We can go together.
Yeah, this is why I don't feel confident. I can't remember any steps for some reason right now.
No, I have Anna. Anna?
Sorry about that. Is it lambda squared minus 2 lambda equals 0?
Y minus 2.
To what? What did you say?
So Y minus 2. The Euler
Oh,
equation.
wait. I'm sorry. I was looking at the wrong one. Lambda squared plus lambda.
This is Y.
Or, okay, plus 1.
1 equals 0.
Yeah.
And so you solve that, you get that's lambda equal plus minus I. And so the answer is capital Y of X equals A or C1 cosine of X plus C2 sine of X, because alpha is 0. And then you go in your second step, and you want to write down the formula of YP of X. Then you need to see that for YP, you have two pieces. So you need YP for this piece first. So that's 1. So let's say we write the YP for the first one. What's going to be here? We got, what's alpha here in this one?
Is it 0?
0. So here we got alpha equals 0. And what's n for this one?
1.
1, because it's x to the power 1. So we got n equal 1, alpha equals 0, beta equals
1.
1. That's beta right there, 1. And so we are going to check alpha plus I beta is 0 plus I, which is I. And yes, this is a solution. And because it is a solution, you need to start by multiplying by x. And now using p, using n equal 1, you want a polynomial of degree 1 times cosine, then a polynomial of degree 1 times sine. And so you want ax plus b cosine x plus cx plus d sine x. And all of that you're multiplying by x. So that would be yp if we had only this piece. And then you got the second piece plus for that second piece, which is just e to the x, and this is the previous topic, e to the x times pn, and alpha here for this one, alpha is 1. Is alpha a solution of the Euler equation? Alpha is 1. The solutions are plus minus I. So alpha is not a solution, which means we just have a polynomial of degree n times e to the x. And what is n for this second piece?
0.
0. So n is 0. So we just need a constant. Let me not write something that will get some confusions with the e for exponential. F times e to the 2x. That's it. So this is yp. So in a question where I ask you to to give a formula for yp, this is what I expect you to do. I don't expect you to go ahead and solve to find out what the coefficients are. I just want you to do the work that we just did here to give a general formula that would be used to find the constants. See example 3. And you look at this one. You can't put these things on the side thinking that later on it's going to work out. You need to make sure that you work on them as we do in class, because there are more challenging topics coming. When we're done doing this, there will be no time to think of learning. You'll have other topics that will need time as well. All right, anyone who wants to start trying this one?
I can do the first step again if you want me to.
Let's go.
Okay. Lambda squared plus 2 lambda plus 2 equals 0.
Mm-hmm. Then we solve. Then you got it. When you solve this, you get -1 plus minus I as the two roots, which gives you capital Y of X equals C1 e to the negative X cosine X plus C2 e to negative X sine X. That's it. Then you go to the step 2 where you want to get YP of X, a particular solution of this equation. And again, you look at that. You look at that right-hand side. How many pieces do you have for the right-hand side?
2.
2. And those pieces depend on the alphas that you get. Right here, you got alpha here equal -1. And you have a plus, so something else is starting. And after that plus, when you look for alpha, you see alpha is 0. So these two things are different. They have to be handled differently. So here you got alpha equal -1. You got n equals 2 for x squared. And you got beta equal 1 for cosine. Here beta equals 1 for sine. And n equals 1 for x to the power 1. That's it. So you're going to write down the first lambda for the first yp for this one. You check alpha plus I beta. You check alpha plus I beta. That is going to be here -1 plus I. And right there, that's a solution of the Euler equation. That's it right there. So it is a solution. So for that, you need x first. But just for this piece. Now, because n is equal to 2, you want a polynomial of degree 2 times cosine and a polynomial of degree 2 times sine. So that's going to be a x squared plus bx plus c cosine of x plus dx plus f dx squared plus fx plus h sine x, and all of that e to negative x. So that would be yp of x only for this first piece where we are dealing with x squared e to the negative x cosine of x. That's what it will give us as yp. As for the second piece, alpha is 0, beta is 1, and alpha plus I beta is I, and I is none of these two numbers. So there's no solution I. So no need to multiply by x. and then polynomial of degree n equal 1. So that's going to be Lx plus m cosine of x plus nx plus p sine x. And that's it. There's no e because there's no e as well in that form. So that this whole thing is what yp of x would be in this case. Any questions? Now in this one, you write down the formula of yp and solve the equation. And I say solve. Solve the equation, which means write the formula of yp as well, and then take those derivatives, track the coefficients, find yp of x, and then write the general solution. Do we have anyone to share his answer now? Want to try, Mercy?
I can try.
All right, let's go.
For the
The first step is what we just did, right?
so I got lambda squared plus 2 lambda plus 2 equals 0. And so lambda is going to be -1 plus or minus I.
So we got that, and then yp of x.
So the first thing I did was I made a note that n is equal to 1, alpha is 2, and beta is 0. So that means, and this is not a solution, so it's just going to be the polynomial. So I put ax plus b, and then e to the alpha x, so e to the 2x, and then it would be cosine 0x.
There's
Or
no
you just don't have to do that
no
because it's
cosine
1.
coming, no sign, right? That's it. So this is exactly back. This is what we did last time, right? It's back to that. So whenever alpha is 0, you know you're back to that. And so here, you're going to take the derivatives. So what's the derivative here?
So it would be alpha times e to the 2. Wouldn't you have to like do it by parts?
That's A.
Oh, a. I meant a. So it would be a e to the 2x plus 2ax e to the 2x plus b 2b e to the 2x.
That's it. And then you take the second derivative. Then that's going to be 2a. And then 2a 4b 4ax e to the 2x. So these are the two derivatives, and then you're going to track the coefficients. And here you're going to track x e to the 2x, and then you're going to track e to the 2x. So what do we get? Are you still with me?
Yes, I'm working on it. I messed up a part.
Just follow the equations on the board with me.
So the first one, it would be 4a.
4a for the second derivative, and then 2, the first derivative, what?
2a. So yeah.
And then the original function.
It would be a.
That's it. Equals an x e to the x on the right. The coefficient is
1.
1. That's it. So you saw 4 plus 4, 8 plus 1, 9. 9a equals 1. A is 1, 9. Then you go to e to the x. That's 4a plus 4.
Would it be 2 times the coefficient from the original function?
Oh, that's 2, right? You're right. It's 2. So that's going to be 9, 10, 1/10. Thank you. And so second derivative again here, we got 4a plus 4b, and then let's go.
And then it would be a plus 2b times 2.
2b, and then twice the original function,
2b.
b. And the right-hand side,
0.
0, because there is no e to the 2x by itself. So that's it, and we solve this. So this is 4a, 4a, 2a, that's 6a, 4b, 4b, 8b's, and then b, 10b's equals 0. So you get b equals minus 3/5 a. So that's minus 3/50. So you got your a and your b. I don't know why I wrote a capital A here. You got your a and your b, so you got your yp of x equals
b1 10th x plus minus 3/50 times e to the 2x would be y.
That's it. And so from there, you get little y of x equals the solution of the homogeneous problem. That's c1 e to negative x cosine x plus c2 e to negative x sine x plus 1/10 x minus 3/50 e to the 2x. Any questions?
I have a question about what functions we're tracking coefficients for. So say, for example, on the right-hand side of the original differential equation, we had x squared e to the 2x. Then we would track x squared e to the 2x, x e to the 2x, and then e to the 2x.
Yeah.
Okay, thank you.
Anything else? Okay. So the functions you're tracking are always going to be either alpha x and then all the powers of x next to it all the way down to 1 from the n that is in the original function. Okay, now let's try another one. Let's say this is the equation, and again, you need to solve using the method of undetermined coefficients. Want to try, John?
Did you say my name?
Yeah, I ask you if you want to try.
I'll pass on this one. I'm still not very confident how to work these yet.
Okay. So read.
You said read?
Yes, can you try this one?
I think I know the first step, but I'm not sure I can get any further than that.
Let's go.
Is it lambda squared minus 2 lambda plus 1?
Which solves S?
That's lambda minus 1 squared, all squared.
So the two solutions are equal. In this case, how do we write the solution?
I'm not quite sure.
It would be C1 e to the x plus C2 x e to the x.
Okay. Thank you. Now in the second step, you want to write down a formula for yp of x. Do you want to try, Preston?
Yeah, so I think the formula would be
So let me tell me here, what's n?
n is going to be 1,
Alpha
alpha 0
and beta
is 1.
1. Good. So you had to try alpha plus I beta, which is 0 plus I. Is this a solution of the homogeneous problem?
It's not.
No. So it's not. Therefore, there will be no extra x. Therefore, what's your answer here?
It would be ax plus b
Mm-hmm.
times cosine x
That's right.
plus cx plus d times sine x.
That's it. That's correct. And now what you need to do is take the derivatives and then track the coefficients. So let's do the derivatives. Derivative, these are products. So you apply the product rules. Derivative is a cosine x. Derivative of cosine is minus sine, so that's minus ax plus b sine x. Then derivative here, that's going to be plus c sine x. Derivative of sine is cosine, that's cx plus d cosine x. Then you find second derivative. Derivative of cosine is minus sine. Here again you have a product, so minus a sine x. And then derivative of sine is cosine minus ax plus b. Cosine x plus c cosine x plus c cosine x. Then derivative of cosine is minus cx plus d sine x. So here are the derivatives that you need. And now you need to get into those equations and track the coefficients of x cosine x, x sine x, cosine x, and sine x in this order. So for x cosine x, what do you get? You look at that function, you go to the second derivative, and you look for x cosine x. You got some here. That's minus a and then none here, right? That's the only x cosine x for second derivative. So minus 2, you go to the first derivative and you look for x cosine, and that's it. The only one is cosine, see? Plus the function. That's the function. X cosine is a equals the right hand side of the equation. X cosine is 1. Then you go for x sine, it's right here. Minus c. Then minus 2, you go to the first derivative. You look for x sine, that's it, minus a. And there's no other one. You go to the original function, x sine. That's it. C. Equals right hand side of the equation, x sine is 0. Are we all right? And right here, you can see in the first equation, a cancels. You get c equals minus 1/2. The c's cancel here, you get a equals 0. And you can go and track cosine. Cosine, that's minus b. C plus 2c. And there is no more. Then you go minus 2, you head into the derivative. Cosine, that's a. Another cosine, that's d. Plus you go to the original function, cosine, and that's b. Equals right hand side, cosine is 0. The b's cancel. We have a and c, and we can find d. So 2c is minus 1. So that's minus 1 here. Minus 0. Minus 2d equals 0. So we got d equals minus 1/2. And then you go for the last one, sine x. Sine x is minus a, minus 2a, and then minus d. Then minus 2. Sine x in the derivative, minus b. Plus c. Nothing else. In the original function, sine x is d. Equals right hand side 0 for sine. And so you can see the d's cancel. And we can get b. 2a minus 2a. A is 0, so that's 0, 0. And minus d is 1/2, so you get 1/2. And b plus 2b. And c minus 2c is minus 2c is plus 1/2. And d cancel equals
Shouldn't it be 1?
where?
Minus 2c, because c is negative 1/2. So minus 2c should be 1.
Yeah. That's right. So that's 3. B equals minus 3/4. That's it. And now you can write down what is yp of x. And that's ax plus b. A is 0. B is minus 3/4. And then c is minus 1/2. X, d is minus 1/2. And that's sine x minus 3/4 for b cosine x. And the solution of the problem is the solution of the homogeneous problem. And that's how it ends. Any questions? All right, if there is no question, then we are stopping here today. Thank you very much.
Thank you.